What another beautiful day on ASU's Tempe campus. Time to do a little documentation of my midterm project for interactive environments. Now, I must apologize in advance. A majority of this, in fact all of it, was built during spring break. Thus, at the time, I did not know that we had to create video documentation. So from here on out, I'll be walking you through the code, kind of piece by piece, explaining what each part or section does. Furthermore, yesterday, I solved two key problems I was facing. The first being color. This section here deals with color and randomizes the change of color every time there is motion detected. Down here we have distortion. Over here we have the shape being drawn in the middle of the sphere, and here we have the sphere that surrounds the shape down here. On top of all this, we have a camera which controls the space, and then this P motion, this is a subpatch. Oops. This P motion controls the oscillation of the object inside the sphere. So I'm going to clean all this up, and then I'm going to show you some visual examples of it actually working in motion. So until next time. And we're back. We got everything cleaned up. We have everything in a nice presentation mode now. Oh, can't find my mouse. There it is. Okay, great. So I'm going to go back over what you saw originally in that big mess, and I'm going to give you a little visual example right now of everything working together. So basically we'll do a full-fledged explanation and tutorial of this motion-based visualizer system. So first thing first, you have this toggle here, and if you triple click on this button, you'll turn the system on, and click again to turn it off. So let's do that. So there we go, we got the system on. Put my hand in here so you can see the movement. And we stop moving. See it expanding. Now, my recommended settings are changing this to 0.9. This is the camera control. So we're zooming in on it a little bit. And then this inner shape, the one that's controlled by motion, dropping that to 0.4 in terms of its scale size. Do that, and you have a very cool environment and visualizer, controlled all, of course, by the movement. So, another cool feature, we can go into full screen by hitting the escape key. So now we're in a full screen mode. Again, control it. Stop moving, it expands. So, the question then becomes, how is this done? How does this work? Why does it work? Well, let's get into that. Okay, we're back and we're in full screen mode now, as promised. Looking at the patch, obviously it looks significantly different than it did prior to this video, or prior to this portion of the video rather. So I'm going to walk through everything step by step, kind of with a top-down approach. That way we can kind of understand how this patch is working and how we're creating the very cool visuals that we're seeing. So, first and foremost, we have this red panel directly here. So this panel simply turns on the system using this big toggle here. If you move down, well, this is turning on a render, and this render function here, or sorry, this subpatch for rendering, is rendering all of this stuff here in the blue panel. Now, while we're in the blue panel, we might as well talk about it. So, in this area, in this area here, on the blue panel, this is that inner object, or that inner noise that we're able to control with our motion. That's what all this is. In fact, really what's going on is this JIT-GL grid shape is working to create that object, of which is being distorted and transformed over here. So, in short, how all of this in the blue panel is working, how all this code in the blue panel is working, it's simply taking data points from a matrix and then plotting them and then adding a distortion and a GL effect to them. or shape rather, actually. GL is used a lot with 3D shapes. Moving up, here we have the sphere. So when you're looking at the visualizer and you have that inner object that you're able to control with motion, there's that background object, which is a sphere. You can obviously change that to whatever shape you want by clicking this. If I go to Control E, you can change that right here to whatever shape you want. You can also do that in the presentation mode. But this just creates the background upon which the visualizer, the motion controlled visualizer, is projected onto. So background, foreground. Okay, moving back up top, in this orange panel, we have the camera controls. So obviously this is where all your camera stuff is controlled, like how close or far you are from the objects. Pretty simple stuff there. Moving down into the screen panel, we have the color, right? So I'll get back out of this so you can actually see the patch cords. So obviously the color is random and it's selected based on your motion. So every time you move and the visualizer catches that movement, well, it changes the color. So this upper portion here is connected to the sphere. So this is changing the background color of that background sphere. I also have it delayed by about a second. That way the color isn't changing as intensely as it does with the visualizer. So here the visualizer's color is changing constantly with every bit of motion it picks up, and it's being fed into here. So how this actually works is you have these bangs which are triggered by the motion over here. So you turn the system on, you come down, it comes down, it turns on the motion. This is a pretty cool sub patch actually. We'll take a little look at this. And we're opening and closing the webcam. So this is a little switch gate, and it'll open and close the webcam. I don't know if you can see that at the top of my, yeah, right there. There's the webcam. Look for a little white dot. Yep, so cool stuff. That's how the webcam's working. That's how it's turning on, actually. And then actually there's all the frame differencing and other components that allow for motion to be detected built right here in this subpatch. So, okay, turn the system on, it turns on the camera right here, and then as soon as it starts picking up movement, well, obviously these are triggering bangs and the color is changing. So let's try it out and we can kind of see how things are working in the code world. There we go, we got the camera on. I'm not moving. I've moved. You can see the bangs turning on right here. On. A little bit of movement. Off. So that process repeats, and then obviously, when you're in full screen, so I'm moving, I stop moving, it expands. So now you have a pretty solid understanding of how this and this work. We can throw them up side by side and kind of get a good little look at how they're working here. Here we are back in presentation mode where we can kind of play around with the patch and look at some of the other fun things it can do. So you can change the background shape here. Oh, I gotta go into... So the background is all these lines you see that are not being moved by your motion. So we can change that to a, oh, it's not here. Change it to a torus. So now it'll look like that. Also very cool. Or you could even change it to a circle. It's a little crazy. A lot going on there. And of course, you could change it to any of these other shapes. So we'll go back to the sphere. And then we move down into the inner shape controls, where we can control the inner shape, so what is actually being controlled by our motion. and changing colors rapidly. So we can change the noise type. So that's pretty trippy. And this is how the noise is being drawn. Of course, it could also be changed to, I don't know, let's try transfer saw. Not much a big change there. We'll go back to the Veroni. Also, what's really fun is to change how it's being drawn. So I really like the points. I think it's super elegant as a shape, and also very satisfying. What else do we have here? We have polygons. Could try that. Now it's just a blob, really. Not so interesting. Quadrants. Pretty similar to the original tri-stripe. But I think you get the point now and can see how versatile this motion-based visualizer is. Thank you for taking the time to listen to me drone on and on. I hope you enjoyed this, but even more, I hope you enjoyed playing with it. Thank you.